I extend a warm and exuberant welcome to each and every one of you. I am absolutely delighted to be your host for this insightful occasion, PMCC's 6th Brain Huddle webinar of the year. I'm Dini, and I am here to make sure your experience is nothing short of extraordinary. Together, we're embarking on a journey of exploration, insight, and innovation. First and foremost, on behalf of the entire PMCC family, I extend our deepest gratitude for your unwavering support. Your presence here today fuels our passion to continue delivering meaningful and enriching experiences. The essence of our commitment to your development comes alive in this sharing session. Strap in as we journey into a dimension of wisdom that knows no bounds. For those who have yet to discover the wonders of PMCC, let me shed light on our essence. Our forte lies in project management and consulting, as seen in our promotional video, spanning the vast expanse of industries, with a particular focus on construction and intricate world of railway systems. PMCC, an acronym pulsating with energy and purpose, embodies project management, coaching, and consulting. Now, about Brain Huddle, it shines as a guiding light of wisdom, a rendezvous where experts from different spheres unite to illuminate your understanding of the current market, enabling you to capitalize the knowledge in your field of trade. It is a privilege to introduce our esteemed speaker for today, a titan in their field whose wisdom will undoubtedly leave a mark. Ladies and gentlemen, meet 𝗪𝗂𝗁𝗂𝘁, a maverick reshaping the transport realm, a passionate proponent of sustainable industry norms, and an engineering virtuoso with a remarkable 26-year narrative across various fields of engineering. Today, he unveils the treasure trove of wisdom, a discourse on railway asset management, unraveling the intricacies of OPEX, asset optimization, and future trends within this industry. Okay, before we dive into this riveting journey of insights, let's lay down some house rules. Consider it our blueprint for seamless engagement. First of all, for those who are ready to forge connections, do not hesitate to activate your cameras and let your expressions weave tales. Secondly, please do activate your mute buttons to orchestrate a smooth performance, allowing our speaker's voice to echo with perfect clarity. Thirdly, questions, the essence of curiosity. They are not just welcome, they are celebrated. However, let's save them for a grand finale. The floor will be yours, so unleash your inquiries when the moment beckons. For those who prefer the shadows of shyness, our chat box is your canvas to cater for your curiosity. And now, with the stage set and the rules etched, I am thrilled to yield the spotlight to none other than the maestro of the hour, 𝗪𝗂𝗁𝗂𝘁. Please.
Thanks, Denny. I've never had so many adjectives put before my name before, but thank you very much for that introduction. Just going to share my presentation. So thank you very much for attending this Brain Huddle session, and thank you PMCC for being an advocate for railway asset management and allowing me to actually present today. So thank you very much. So railway asset management, understanding OPEX, asset optimization, and future trends. My name's 𝗪𝗂𝗁𝗂𝘁. I'm the Managing Director of 𝗪𝗲𝗯𝗶H Proprietary Limited in Australia, and also the Director of AU79 Consulting in Singapore. So 𝗪𝗲𝗯𝗶H, I started up that business about 6 years ago, and it's been going well. A lot of work in the government sector and whatnot. AU79, I started that business this year, so it's fairly new, and looking to expand my work into the Asian market. I'm have a Bachelor of Engineering in Mechanical Engineering, and also an Executive MBA, a Chartered Practicing Engineer in Mechanical and Structural Engineering with the Engineers Australia, a member of the Institute of Company Directors, 26 years and counting in the realm of engineering, and I have a vast background in engineering because I'm just really passionate about engineering, but I have worked in automation, automotive, defence, mining, oil and gas, and For the past, I'd say 14, 15 years in railways, both rolling stock and infrastructure. So about my businesses, so Railpreneur, as I said, was established 6 years ago in 2017, and AU79 established this year. Both are focused on transport and mobility, consulting and advisory services, which include project development, technical advice, and CapEx and OPEX audits, reviews, and advice. I have a very strong passion about techno-economic evaluation and reporting. I believe that there needs to be that connection in order to make right decisions. And on continuous improvement and implementation, a big part of my business is partnering and collaboration. And you'll see that in the next slide with who I've actually partnered with, and obviously with PMCC for this presentation, and also looking at how we can collaborate in the future. Above all else, it is about delivering and realizing value. And you'll see in this presentation that I actually harp on a lot about value. It's not just about cost reductions. It's not about, whether we choose one product over another because it's cheaper. It's about delivering value and over that whole of life ownership of that asset. So my work includes a lot of government sector and also contractor level work with level crossing removal program. I'm in there as a rail technical consultant with 𝗦𝗽𝗲𝗵𝗿. I've partnered with RLB in OPEX work, and we do a fair bit of that in Australia. Our work is primarily with the Department of Transport and Planning, and also with the Cross River Rail Delivery Authority. I have partnered with Bellwether Consulting for work with Rail Projects Victoria, have done some financial modelling work for the Australian Rail Track Corporation, or ARTC, and have been involved in Downer Infrastructure Services, which is now DT Infrastructure, since their takeover by Bermuda. Partnering organisations, PMCC, obviously why we're here today, RLB, 𝗦𝗽𝗲𝗵𝗿, Bellwether Consulting, and also Mercado Group. So let me jump into railway asset management. So what is railway asset management? So the term gets used a lot, but it's rarely understood. It is about that whole of life ownership, and it is about how do we ensure that we are maintaining and looking after what we actually invest in. So, but asset management needs to come in at ideation, and that is probably one of the downfalls within asset management across a number of projects that I've been involved in, and a number of projects that I've actually heard about, is that we don't actually look at OPEX at the very start of project conception. It's techno-economic in nature. It's about finding a balance between the technical requirements versus the cost. But at the end of the day, it needs to be focused on value. There's the marriage or union between CapEx and OPEX. It's that whole of life segment from end to end. By the time the money that we invest in a project towards the end when we actually dispose of the asset, or we renew the asset or replace it. It's about a strategy of continuous optimization, continuous improvement, which is often overlooked because we don't focus on the main part of what is asset management, and that is the people. People are a key factor in all asset management decisions. And then we move on to the processes that we actually employ, and that's not just the processes that govern how we do things, but also those processes which are related to such things as the configuration, changes in law, changes in supply landscape. It's about that adaptability aspect. And then we move on to disposal of the asset, embedding design so that it's designed to construct or designed to repurpose or designed to recycle. So those are the terms that we should be using in asset management. Considerations to the environment, it's a hot topic at the moment. And so we really need to, really focus on those, on that part of asset management, because it's going to really drive the behavior about what we choose to take forward into our projects and what assets we're going to want to have in our projects. And the one thing I'm going to discuss today, and you'll see, and it's the flavour of the presentation as such, it's about delivering sustainable value. And when I say sustainable, it's not just the environment. It's not about that triple bottom line, in terms of cost, social cost, and environmental cost. I'd like to add another dimension to that, and that is generational cost, because we don't see in our asset management work, how do we take it forward so the generations after us are actually benefiting from that asset? I'm working on projects now. I'm in my mid-40s, working on projects with a design life of 100 or so years. I'm not going to be around to actually see them in when they come to their end of life, but my kids will, and their kids will. And I want them to be able to, see that asset actually become something else, or actually get repurposed or add value to their lives. So, I would like to talk about China. I worked in China in 2007, albeit not in railways. I was actually in automotive. But back then, it would take well over a day to travel from one part of China to another, particularly people that I worked with around Chinese New Year, going back to their families. And then fast forward a couple of years later, and that long distance travel is no longer a day or over a day. It's a matter of hours. So it's actually adding benefit to the lives of people. So that's where we need to focus on sustainable value. How do we make it generational? So understanding OPEX. So we have a new asset. We celebrate it. It's great. We have a CapEx project that comes to an end. We've got politicians doing the ribbon cutting. It's reputational exposure. I remember those days being on a project, particularly one that comes to mind is the South Marine Rail Extension project, which was my first infrastructure project. It was important to me because that project was in the area that I actually spent my childhood years. Seeing a project, being part of a project where you're delivering it for a community that you used to live in is exciting. I was there on the first train in 2012, my phone camera in hand, and videotaping the first train going down the line. It was great. And a couple of years later, I had the fortune of actually being part of the next extension to that line, which was, again, a celebration of delivering a wonderful piece of community asset. But then the reality hits. It's the ongoing cost of keeping that asset. After we finished the South Marine Rail Extension project, we sat down and we said, okay, how are we going to maintain this thing? It wasn't thought about before. So we actually went through the exercise. And it's very, very hard because we do it as a reactionary thing rather than something that's proactive during the project life cycle. So by the time we actually get to the point where we're handing over these assets, we're wondering, what is the actual cost of ownership? And that's what we're here to discuss today. Bit of an issue. Oh, there we go. All right, so what is OPEX? Operational expenditure. Some would say that railway signalling is a dark art, but I would say OPEX is much darker. OPEX is that part of the whole of life ownership which gets little attention. And so as an asset owner, you should be concerned about the cost of ownership. OPEX is about the preventative maintenance, reactive maintenance, labour, upkeeping staff competencies, operational systems and tools, utilities, materials, renewals, replacement, and disposal of an asset. It's a highly asset system and configuration dependent exercise. And that's where the difficulty lies, because we have to actually look forward at planning. How are we going to actually maintain this asset? Is it going to be nighttime or daytime? How are we going to have the resources to actually maintain the asset? These are the things that we go through. So this is why quantifying OPEX is so hard, because we have to actually go through that exercise. There's no OPEX lens at ideation. So we go into a project, we deliver it, and then we think about how we're going to maintain it. And by then, the asset's already in operation. So we have to backtrack, and we use known data or known ways of working. And so the costs of maintaining an asset are usually escalated and probably not true to form. It's complex. There's no two ways about it. Trying to forecast costs on how we're going to maintain things, how we're going to look at contiguous a contiguous array of assets, and how we're going to get in there, do work during very short timeframes. It is a minefield, and it gets harder and harder when there's other constraints coming in, such as events, etc., and also an expectation that the railways need to be operating 24/7. So there's enablers and there's constraints. And sometimes the enablers can actually become a constraint, unfortunately. And we also have poor records and system metrics. We don't really keep those things, which are really important. We don't dive into that data enough. So forecasting OPEX. We need to understand the asset delivered, the overall scope, the systems, the subsystems, the interrelationships between other disciplines. It is important that we actually have that quantification. When we do harness that knowledge, it makes it a little bit easier to actually go through the exercise of planning what OPEX is going to be. We need to look at the quantification of assets, old and new, what's coming out and what's going in. And then and the interfaces between those assets. Obviously, with new assets, it's got to interface with an older asset at some point. So there's going to be some issues there. Performance history of similar assets. How do we correlate OPEX costs against performance history? Now, if we don't have real performance history, or we've got amount of data that we're actually not exploring, we make that that decision around a very poor set of metrics, and we're not really getting to the heart of what is a maintenance of an asset. We need to estimate the intervention for unplanned events. So how do we go about doing that? We might come up with a percentage figure, or we could use some system science, and system science using reliability, availability, maintainability, and safety is probably one of those ways how we can get to the reactionary bit. And site-based inputs. Obviously, there's going to be nuances in the networks that we work in, and we need those insights so that we can actually make an informed decision around OPEX. It could be it's terribly hard areas to access, etc. Processes and plans. So we need to actually have really robust technical plans, procedures, and inputs, and they could be inputs from OEM manuals, or they could be actual technical data or experiences from other networks. But we need to sort of get in there and really understand how we're going to maintain the asset in the first instance. So we're going to run a poll and basically answer the question, yes or no, do you think data is used effectively in the OPEX decision-making process within your organisation? Please just answer the first question. There is another poll after this set of slides. So if you can just answer the first question, that would be great. Okay, quite interesting because we're actually seeing more yeses than nos. Although it's kind of like watching a bit of a game happening here. And no has taken over. Okay, it seems like we have a bit of a 50-50 break here on yes and no. So that's great. Maybe we can actually discuss that that result a bit later at the end of this presentation. Before I continue, I probably want to discuss a particular bit of technology that I was actually made aware of, and I actually have seen work, is a system called POS from 𝗪𝗏𝗏𝗏. And basically they use data from the field so that the a point machine is actually completely monitored throughout its whole movement. So as the blades are moving from the stock rail, the actual system is being monitored and actually has thresholds. And when that threshold is breached, that data actually is used in detecting where in the actual point mechanism motion the issue that's occurring and where a maintainer should go and actually focus on when they get to site. So it's actually cut down the time on site from like 45 minutes to address a particular issue down to possibly around 15 minutes. So this is where data and decision making can also become an automated exercise. So with data, we need to ensure that what we're obtaining is of high fidelity and has no noise. So have you ever felt that there is too little data to understand OPEX, or has there been too much data to understand OPEX? So William Blake stated that the path of excess leads to the palace of wisdom. Now, what that means is, do we collect data and then never really learn from it? But we should learn from it, because at some point we'll say we actually have enough to actually make a decision. Data should be used to inform decision making, but we're amassing it and actually not using it quite well, at least from my experience. OPEX relies on good informative data and offers the fidelity to make decisions effectively and efficiently. You don't want to be sitting for days over boiling over data to actually make heads or tails of it. We should actually have the data with us within a day or so and actually make that decision. So I like to focus on CapEx and OPEX. So CapEx and OPEX are disconnected. We never align the two. OPEX is reactionary after we've finished a project, but CapEx is like the golden child. It's a tale of two cities. So OPEX rarely gets the attention that it deserves, and is usually outshined by OPEX. But OPEX is where the real work frontier is. It is where we actually are able to transform the way that an asset behaves. And we're able to transform how and inform how a project should be delivered if we actually look at it in detail. So what I'm devised here is a method of actually aligning CapEx and OPEX, trying to get a union between the two, cross-pollination between various aspects of CapEx and OPEX, so they're informed simultaneously. It offers greater certainty. OPEX is more accurately forecasted, and we realize value. What we can do by having this union is we're able to redirect benefits from CapEx into OPEX and vice versa. So enhancing that OPEX frontier is through the application of continuous improvement. Continuous improvement means that we can actually work on more efficient means to maintain an asset. That type of work can feed into CapEx projects to actually drive down the cost of delivering a project. But likewise, we can grab stuff out of CapEx and redirect it into OPEX to benefit the OPEX outcome. But in order to achieve continuous improvement, we need to ensure that we're always challenging what we know, that we listen to our peers. This includes executives listening to their staff. We need to learn actively and beyond our industry. We need to engage with earnest, and we need to be genuine about the positivity that we want to bring to the industry. It needs to be for the greater good, not just for personal achievement. And change is fundamental. We need to be ready to adapt. Improvise, adapt, overcome, which is one of my personal mantras. So we'll jump into asset optimization. Now, I want to introduce this topic by quoting 𝗪𝗲𝗍𝗪𝗍𝗍. If you don't understand how to run an efficient operation, new machinery will just give you new problems of operation and maintenance. The sure way to increase productivity is to better administrate man and machine. So where do we begin? So my question, and this is a question that the audience will be requested to answer, is what is the common denominator of the rail industry? I'll leave you to think about that for a moment. And we'll just jump to the next slide, which is the question and display of the answers. No one's in an answering mood. I think everyone just wants me to give them the answer. So I'll jump to the next slide. So this picture might allude to what is the answer. Time. Taking a passenger from A to B is all about time. It's the efficiency. It's making best use of people's time. That's why we have things like Wi-Fi on trains. We have entertainment on long-haul journeys. We have food and drinks. Making a passenger's time relevant and important is a fundamental aspect of train journeys. So when we focus on the asset and the fundamentals of systems, subsystems, and asset functionality and operation, we're talking about RAM. Reliability, being consistently on time. Availability, operational all the time. Furthermore, can an asset be accessed in a timely manner for maintenance? Maintainability, repair with little downtime. And it's also the foundation for availability. And then we have safety, ensuring safety all the time. But a safety incident can actually incur downtime into a network. It affects maintainability. It impacts the reliability and also the availability. And safety also impacts the reputation of an operator. So, in asset optimization, we need to focus on continuous improvement. First and foremost, people. If you want to embark on a continuous improvement culture within your business, you need to focus on people. You can have the best processes, have the best technology in the world, but unless you have your people set in the right direction, it will fail. Then we focus on process, and then technology. So people are the most important factor in asset optimization. If there's an unwillingness of the executive team to espouse a continuous improvement culture, then improvements will fail. I've worked in multiple industries and have seen this firsthand. If there's an unwillingness of personnel to adapt and to adopt continuous improvement, improvements will fail. The rail industry is its own worst enemy. And this is partly due to its risk-averse nature, even when improvements can benefit safety. So in terms of adoption, there is a cultural challenge around about the 14 to 18% adoption mark. This is called the Valley of Death. And this is where a lot of good technologies or processes just come tumbling down. And it's driven by culture. The challenge is, how do we address the people aspect in continuous improvement? We need a culture that's inclusive, gives people a voice, it's proactive and encouraging, gives people access to tools and funds, and most importantly, celebrates failure just as much as it does success. We don't want to kill people's ideas. We want them to keep going at it, have that grit to be successful. And you should always remember this, coined famously by Peter Drucker: culture eats strategy for breakfast. So when it comes to people, I like to say that hub and spoke leadership provides a very supportive framework for continuous improvement. Yet I've worked in organizations which are very autocratic and have seen continuous improvement work. My first job in engineering was with an automation company, very autocratic, family-owned business. And I was given a task to find a way of redefining a bit of equipment. It wasn't just an engineering exercise, it was also a cost exercise. But they wanted to improve, and it came down from the executive. So ways in which we can engage people. So let people talk and let them be heard and acknowledged. Don't be negative in critiquing their suggestions, and don't kill an idea without giving it some thought and mental processing. There are tools at hand, value management, which I've personally used, which is an immersive engagement where improvement is driven by those involved and those involved in a day-to-day business, and they become advocates for improvement. Design thinking and understanding from people within the business where the pains and gains lie. Listen to them intently and genuinely. The most important point is that there is inclusiveness end to end. Then we come to process. Process improvement provides a functional groundwork for continuous improvement. Process change requires people to be open and adopting and adapting to the change. Redefining processes includes consolidation, rationalization, looking at cross-pollination of exercises to improve the value chain, remove waste and remove cost, and reduce cost. Process improvement lays the groundwork for the exploration and realization of other opportunities. And once you have people proactively participating, it becomes a perpetual cycle. Process improvement delivers value. So I'll take you back to an example out of, from my experience. So a few years ago, we were looking at a train-borne monitoring system, and it was basically a device out of the UK. The device was from a company called Perpetuum, which I believe now is owned by Hitachi Rail. But it was a wheel sensor that sat on bogie equipment, measured vibrations on that equipment. I guess the beauty of that system was that the actual sensors were powered by the vibrations that they're actually measuring. So there was no additional wiring, no external power sources. Wirelessly connected to the data acquisition system, that data would go off, be processed, got it the next day. Time efficient. But that data not only could tell us information about what was happening on the bogies, we could extend the use of that data to tell us what is actually happening on track. I'm a big proponent for using revenue vehicles as our inspection source for asset maintenance and infrastructure inspection. We don't have to run vehicles every 6 months, get data that's 5 days old, and then try to make decisions on that. When we have day-to-day data that can tell us trends in what's happening with our network, that is a much better way of getting down to the nuts and bolts of how the issues that reside in our rail networks, but also how to best maintain it. It gives us more certainty around OPEX. This particular system could actually move OPEX into on condition rather than abiding by an OEM manual or a technical plan that is based on legacy know-how. One of the processes that I found works well, there are other processes out there like Agile, etc. But Lean Six Sigma is probably one of the best tools out there to really get OPEX costs into the right frame. It involves standardization. It will reduce cost, reduce risk, reduce and optimize time, offer greater certainty, and a better return on investment. We should be identifying how we can exploit technologies to not only just do one thing, but how they can do a gamut of things across the business and value chain of a railway operation and maintenance. So then we focus on technology. Now, as I said before, I worked in a number of industries before I ended up in the rail industry. And I've used this philosophy in all my work in the rail industry. Don't think that the rail industry has all the answers, because it doesn't. And the rail industry, much like some other industries, don't look beyond their boundary. They don't look over their neighbour's fence to see what their neighbour is doing. So we really need to look beyond our boundaries. We need to gain experience from those other industries, and we need to learn. So when I was involved in train design, that was the first job I had in the railway industry, was working on the interior systems for the 𝗪𝗲𝗲 train in Sydney. I brought my automotive experience into that train design, adopting a design for manufacture philosophy. I also had to redesign structures within the train. And I offered up new materials and new assembly methods, optimizing the structure, taking away weight in the train. Effectively, I dropped the train weight by 7% just through using smarter materials. Today's rail industry is still wedded to the past, and it should be looking to the future. Looking at how other industries are tackling or solving relatable or similar issues is going to be key. There's also a number of ways how we can implement technology. A very straightforward one is commercial off-the-shelf systems. Now we can search across all industries for a one-stop shop product. It may need some specific customization, and then we can deliver it into the rail industry. One that I'm actually quite interested in is doing the mash. And that's effectively bringing in parties to partner and actually create new ways of working, better ways of working. An example of that is that the rail industry suffer from delay to getting onto track to maintain an asset because we can't isolate an electrical system on time. We can lose hours in trying to isolate the system. So I remembered an article that I saw in a mining journal a few years ago, and I made contact with that company to try and find out about their product. And it was really, really good. It meant less downtime, more efficient isolation of systems using basically a semi-fail-safe device. But I wanted to bring it into more of a railway flavour. And at that time, I was exploring the use of track shunting systems that were part of an IoT, Internet of Things arrangement. So the idea was about bringing those two companies together. An IoT platform that could offer a SIL3 or SIL4 fail-safe operation, and an isolation system which would reduce downtime and actually widen the opportunity to do more work during a track possession. The system needed a bit of work in terms of a safety case and whatnot, but we never actually got that far. But these are some of the opportunities that we could be looking at. So in that example, we're moving from a traditional method of electrical isolating systems to challenging the industry as a whole, including other industries, and moving to soft locking of electrical systems with fail-safe technology. And then there's making the future work, which is about working with institutions, finding research, finding people who are looking at real issues that exist within the rail network. And they're not just engineering issues. So identifying that research at an early stage allows us to customize it and make sure that it's ready for commercialization. And it can be delivered to the rail industry without a hiccup. So in demonstrating value, we need to actually focus on financial modeling. You know, it would be great if the world was run by engineers, but very idealistic. So we need to actually demonstrate financially that these systems, these new technology, these people and processes actually add value and satisfy business requirements. So financial modeling takes in those inputs, but in order to do proper financial modeling to demonstrate where we're taking the current business to where we're at, to a new level, we need to understand the fundamental part of OPEX. That is why we really need to dive in and understand OPEX as it is currently. When we can actually demonstrate that we've got a return on investment, we have a baseline from which to work to. We need to demonstrate payback. As one of the important factors in financial modeling. So too is the benefits cost ratio. And what does it mean in today's money? Furthermore, we need to get to a point where we can cash flow those initiatives to help better understand the money movements year on year. Current economic activity uncertainty is a challenge in financial modeling. And because of those assumptions we must make, we need to ensure that we can come back to that financial model and revisit and recalibrate those models in the changing economic climate. So foundations to success. So we need to return back to the growth path. So what is growth? Growth can take many forms in the rail industry. It could be increased reliability. We'll see a migration of people to public transport, capturing that discretionary use of public transport, potentially. Reducing operational costs that could lead to optimization of ticketing prices. If we can maintain an asset better, then the cost of ownership of the railway comes down and makes it more affordable. Reduction of costs will see money free up for greater improvement works, more projects, more system growth, investment in technology. Supply chain growth and prosperity, growth in skills. Growth can be found in both tangible and intangible factors. So I'd like to touch on future trends. Some of these I'm actually quite passionate about. And I like to sort of hope I can impart some advocacy in terms of these future trends. So we're seeing this now, the advent of digital models, from virtual reality and haptics to augmented reality and artificial intelligence, and building information models, or BIM. Now, it's great that we have these digital models. The problem is that we have too much proprietorship. We don't have an ease of migrating data from one system to another. So we have to have data administrators sitting in between. Sometimes that data is lost. Sometimes the data is not at a level which provides great insight. So earlier on in my career, I used to do finite element analysis, explicit finite element analysis to be exact, which is high definition, short time step math modeling. So I used a bit of software called 𝗪𝗲𝗏. I have used other softwares as well. But the fundamental aspect of that code was that it was developed in the 1970s and was made public domain. Even though that the creator of that code went on to create 𝗪𝗲𝗏 as a business, other companies picked up on that code and have benefited from putting greater enhancements around that code. The thing is that that code is based on a fundamental baseline. So there's no proprietorship. So we need to move to that as a critical success factor of digital models. It doesn't stagnate creativity or even impact competitiveness, but it makes the flow of information better. The one thing I really believe in is that we can move away from CapEx models. So say goodbye to CapEx and say hello to OPEX. I'm going to use the word servitization. That's effectively assets as a service. We already see it. You buy your Microsoft Office subscription. You've got a phone and you've got a mobile plan. That's an asset as a service. So why can't we do it with railway assets? Particularly in an economic environment where money is not always available, particularly large sums of money to complete a CapEx project. So how do we move to a model where we actually make smaller payments over a period of time? A few years ago, I explored this with some traction substation suppliers, and there was a general interest. It meant that we could actually procure a traction power substation, make payments over a 30-year term. We got maintenance as part of the offering, the opportunity to renew the asset at the end of its life. But we didn't have to spend a lot of money up front. What it also means is that we actually get to a point where we have supply chain certainty and longevity, rather than a supplier having cash flows which go up and down depending on whether there's a project on the go or not. We see their revenue, we see their cash flow flatten out or plateau in a way. And that offers sustainability in our supply chain. Again, offering a generational change to how we deliver rail assets. We need to look at OPEX as the long-term gain. A few years ago, there was a radio supplier to the automotive industry that went into administration, basically bankrupt. It halted the supply chain. It halted automotive production for a particular vehicle manufacturer in Europe. But it's because we don't focus on supply chain sustainability that we have these issues. So in reflection of our discussion today, we need to understand the present and deliver the future. Understanding OPEX is fundamental to ensuring that we can actually take assets further, optimize them. We need to align CapEx and OPEX as an enabler to achieve the best outcome for OPEX, to really harness what those OPEX mean, rather than it being reactionary. In the optimization of assets, we need to focus on the common denominator for the rail industry, and that is time. When we focus on people, process, and technology, it needs to be underpinned by value that delivers time benefits. And we need to demonstrate that value. We need to do financial modeling. We need to cash flow. We need to show the payback period to satisfy that we're going down the right path. And we've discussed future trends. Digitization is here and now, but we can't let it escape us. We can't let it get too far ahead that it's not governed in the right way, that offers benefits, that offers value, or diminishes value to running a railway. And the idea of moving to a pure OPEX model to focus on a quadruple bottom line of cost, of social cost, of environmental cost, and generational cost. So I'd like you to give these points some thought, because they could be game changers in the way that we actually deliver projects going forward, in a way that we demonstrate and really deliver on the meaning of ownership of an asset. Thank you very much for your time today. Now, usually I would go with a Q&A, but I like to open it up a bit because I love learning. I don't espouse to be an oracle of all information related to the rail industry, but I love to learn. I love to expand my knowledge, and I hope that the participants here today are here to do the same thing, to learn and expand their knowledge. So we're going to open it up to the floor, and ask any questions or discuss your experiences. They'll be greatly appreciated. Thank you very much.
So if you have any questions, feel free to turn on your mic or even put it down in the chat box. If there's one question here from Matt Thompson. He said, thanks, Steve. Brilliant presentation. What would you say is the greatest barrier to better implementation of a combined OPEX, CAPEX model?
Thanks, Matt, for your question. I think the barriers are that it's going to be hard to get away from traditional methods of funding projects. I mean, we do have public-private partnerships, which are in effect a way of delivering projects under a finance scheme and with under a payment scheme. But they do involve a CAPEX level of work. What we really want to get to is how do we get assets within that, such as signaling assets, such as traction power substations and whatnot. Those particular assets, how do we deliver those such that we have suppliers in the game and offer that longevity? Traditionally, we would just, even under a PPP, obtain a substation and it's a one-off payment to a supplier. So I think the barriers are more traditional rather than just they're just not more traditional.
There's a second question here from Ed. And which country, in your opinion, has the most advanced rail?
Okay. So I think in my experiences, there would be a couple. I don't think there would be just one, but I think if we really want to learn about good railway systems, we need to look at Hong Kong, Singapore, and Tokyo. I think they offer a greater view of what we could be doing, particularly in some particularly in the Western countries. I think if we had a lot more insight, knowing how China is doing things, like their advancements in rail are exponential. And like I said before in my presentation, their changes are generational. It only I guess probably only took less than a decade for that train to be a slow-moving diesel train to a high-speed rail system. So how do we get to that level? We seem to spin the wheels a bit too much in Western countries.
There's a third question here from Vivi. Thanks, Steve. Very insightful presentation. How effective is rail systems CAPEX in the present growing market of driverless trains, and how can it be more effective?
In driverless trains? Okay. Well, driverless trains would offer a greater benefit in terms of not having a driver, obviously. Having a background in automation, I think automating a system such as a railway, and we've seen it in other rail jurisdictions, Hong Kong, in Singapore, in Japan, and also in Australia with in Sydney, that driverless trains actually can be embraced, and I think offer a really good way of reducing OPEX costs, particularly on the labour front.
Okay, another question here from 𝗪𝗲𝗶𝗿, quite interesting one. Okay, so Fazri says, hello, I am from Sarawak Metro. I am a rolling stock engineer currently developing hydrogen-powered ART. So since hydrogen will be the main source of the operations, how will consume a high peak of OPEX, will it? And please share your thoughts on this.
So hydrogen as a fuel source is something I'm actually quite interested in, particularly in its, I think it's got some major benefits against the traditional EV fuel source vehicles. But look, hydrogen as a fuel source is well, can be made anywhere. So that's one of the benefits of hydrogen. Although there are certain aspects of CapEx and probably OPEX as well on how do you keep those systems maintained and safe. Obviously, hydrogen as a chemical can have some negative impacts, but I don't think that those OPEX issues are insurmountable, or I think they're quite easy to get around, and I think we'll actually see some benefits from hydrogen being used as a fuel source, particularly from a disposal perspective. EVs at the moment, we don't have the ability to recycle EV batteries. I've probably likened it to the next nuclear fuel disposal issue, although it takes up considerably more space than nuclear fuel rods. But we don't have the right end-to-end whole of life cost of ownership model right for EV batteries, and I think with hydrogen, I think we might actually be closer to understanding those whole of life costs. A lot of it due to the fact that its calorific value is most of it gets used in production of traction generation, but obviously there's the issues around maintaining a chemical containing system. So.
Well, your mention of EVs and hydrogen piqued my interest. So I have a question to you from myself. Like, we see how Toyota is coming up with a hydrogen as a fuel source, like the race car which has been tested, the 𝗔𝗲𝗄𝗃, and then we have EVs which are mushrooming like nobody's business now. So what are your thoughts on this between I wouldn't say a war, but like you see Toyota is purely focusing on hydrogen rather than EVs, and EVs that are mushrooming like nobody's business. What are your thoughts on this?
So, as I said, EVs, contain lithium, contain there's cobalt batteries as well, but they use a number of other different products. They're not completely green, still encased in plastics which are oil-based, still have a number of nasties in them. Lithium also being one of the dirtiest forms of mining, and there's also I guess raw material issues that come out of mining lithium. So we've seen in the mining industry, even in the iron ore industry or even other bulk material industries where tailings dams have failed and have polluted and have devastated the environment. Same thing can happen with lithium. Hydrogen. You can set up a plant next to the seaside and generate hydrogen to your heart's content. So, but we don't have some of the storage issues that come with lithium. But as I said, that whole end-to-end life of a lithium battery as opposed to a hydrogen cell system, I do think that hydrogen is going to have a better whole of life ownership and disposal model than EVs.
All right. So we're thinking long-term hydrogen is the solution.
Yeah, I mean that's my personal belief. I could be, shot down in tatters about and bombarded with research and papers, and I'm happy to absorb that information and be otherwise convinced. But I think EVs are a little bit more constrained in terms of total asset ownership, and I think that their actual ownership costs are way more than what is perpetuated in social media and whatnot.
All right. So there's one more question. How are we to manage the software license on the cloud?
Software license.
I'm not sure about this question. Maybe.
Yeah. So when I talk about servitization or assets as a service, it's not so much managing them at a digital level, although they will have digital interfaces and can be managed. If it's a monitoring system, obviously there'll be a subscription for it, or what have you. That will be part of the OPEX model. When I'm talking about asset as a service, it's procuring that physical asset and then paying a sum of money at certain financial periods, which would offer up monitoring and maintenance of that asset. So there's intervention. So it's basically for buying a preventative maintenance package that involves a substation.
Okay. So next up, a question from Hamilton, also from Sarawak Metro. Hi, Steve. How do you manage and improve customer satisfaction by reducing OPEX and CAPEX on aging assets?
So I think we look, aging assets are not they're not going to be detrimental to reliability or OPEX. I think it's how we treat and monitor those assets, and how we maintain them. The more that we maintain an asset, the more it will degrade over time. So the more maintenance interventions, the more it will degrade. If we move to on-condition type maintenance, where we have a monitoring system and we only intervene when it has breached a threshold, that is where we should be heading to, and we can apply this to existing assets. And there could be companies out there that could apply it to existing assets. I know that the POS system could be applied to an existing asset. It doesn't have to be a brand spanking new point machine to attach the POS data acquisition system. It could be an existing device, because all it is measuring the electrical throughput of the motion through the point machine. I do think that we really need to understand our assets more in order to understand how we can reduce the OPEX around them and the opportunities there are. Look, it might be best with some assets, particularly some aged assets that are way too gone, to replace them, but replace them with a system which will allow you to have longevity of that asset and offer up a better whole of life cost ownership of that asset.
Next question again from Ed. Do you think rail network operators could be more incentivized to innovate?
I believe rail operators can be incentivized to operate. I think that comes down to the contract mechanisms that are about whether, and it could be a contract mechanism if it's a franchise operator or a concessional operator, or it could be a state-owned operation. I think there still needs to be incentivization. We shouldn't just it's not a private versus public issue. I think we can still incentivize within each of those types of business models to achieve a better outcome. But yes, incentivization is one mechanism to get the best out of a rail operator.
And the question here from JY, any example of creative use cases of predictive maintenance and managing the big data processing, or example of using this big data to tweak operation strategy to extend asset lifecycle?
Yeah. So there's two, and I discussed them in the presentation. So the POS system from Scicluna Rail uses data and grabs that data and puts it into a decision-making profile. So at the ProRail facility in Utrecht, they have a screen, and I've sat there in front of that screen, and they have an ideal profile of what a point machine operation should look like. Now, and there are two boundaries, one lower, one higher above that line. And as the point machine moves through its motion, it actually gets tracked. So they can actually go down to the asset level and actually see the tracking of that motion. And it's live, and that is data that's coming from site. So instantly, if that point machine exits out of those boundaries, they can instantly get someone out there to react and to repair that issue. But the beauty of the system is that the issue is actually demonstrated by that graphing. So the graph is actually so as the point machine is moving, each portion of that graph is part of that motion. So they can say, okay, well, it's the rotting that's an issue, or there might be an internal issue within the actual point machine. They can actually get to that level with the system. The other way is the other example that I was talked about is the perpetual system. So rather than maintaining bogies or maintaining or overhauling major components of a rolling stock bogie at set intervals, what we can actually do is we can drive that maintenance to be on condition. So rather than maintaining and slowly degrading the asset as we maintain at set intervals, what we do is we extend that maintenance cycle. So effectively, we can probably almost double that maintenance cycle and intervene at those points, and therefore we get longer life out of our bogies. We also reduce the cost of maintaining those bogies. And like I said, we can expand on exploiting the system to look at other parts of the network. So as I said, with the perpetuum system, you can actually see, or you can do trend analysis to find out whether your vibrations are actually rolling stock borne or whether they're infrastructure borne. And you may take 5 days of data and say, okay, well, this red spot continues to to show up on the track. So maybe we should be looking at that track. We could have a twist issue. We could have, you know, a formation degradation issue. We might have a cyclic issue on our track. That's actually impacting bogey performance, rather than just assuming that the issue resides with the rolling stock.
Okay. Next is another question from VV. From a solutions reuse angle, you mentioned earlier about having a sticky beak at our neighboring stations. Can you give some examples, please, with respect to rail systems?
So, yeah, with rail, as I mentioned in the presentation, I looked at the mining industry. I have a partial background in the mining industry. I did some work for them as a consultant many years ago. And I've always kept abreast of other industries, because it's really, I find it's the only way to learn and find out whether there's things there that, you know, could be applied to the rail industry. So, you know, looking at this, you know, mining electrical isolation system. So basically, a guy could sit in Perth and switch off the electrical system at a mine in 𝗪𝗲𝗏, you know, some 2,000 kilometers away. And then all it needs is an electrician to go up and put their padlock on the system, and it's locked out. Happens within about 5 to 10 minutes. So what I was trying to do by combining it with an IoT system that already exists in railway networks, it's an IoT system which has been implemented in parts of Europe. It's fail safe, and every year goes through hacking demonstrations to ensure that it's cyber secure. But combining it with that system such that I can actually isolate the electrical system within the 5 minutes without any manual intervention. So that person putting on the padlock is not even required. And then applying it with, you know, technology which you can already buy for the railway industry, such as, you know, 3-position isolation and earthing systems. But putting it with an IoT level where I can actually use my iPad, or I can even use my phone, and I can actually isolate the system for a possession. So there's no need for people to go out on site, no need for someone to put up an earth wire. So from a safety perspective, it moves to a different level, but it needs people to accept the ability to soft lock rather than hard lock electrical isolation systems. And that's the barrier, you know, and that's the change that we really need. It's a cultural thing. It does take some acceptance, and we need to get through that. And I think that's probably one of the things that we could explore in the future. I think moving towards digital locking of systems is going to be one of those future trends that we'll see.
Okay. So I see that there are no more questions. So as we end our Q&A session, I would like to extend a heartfelt thank you to you for your very insightful sharing session.
Thank you.
I'm sure that the knowledge you have shared has set ablaze the embers of our minds, and we are now infinitely more enriched from your sharing. So this chapter of BrainHuddle might have concluded, but the story of enlightenment continues. By joining us today, you have demonstrated your eagerness for knowledge, and as we conduct these sessions on a monthly basis, we extend an open invitation to join us in future BrainHuddle sessions, a monthly rendezvous where brilliance unfolds. Therefore, if you don't want to miss out, you can follow us on our social media, subscribe to our newsletters, or check out our website at www.pmcc-corporation.com. We eagerly look forward to reconnecting with you. So as we part ways for now, I would like to remind you all that the quest for knowledge is never ending, and the path to progress is paved with curiosity. Until we meet again, Goodbye, and may your day be nothing short of exceptional. A lot of thanks for you, Steve.
Thank you, Steve.